Here in session 101, we're going to be dealing with ratios and proportions. These are concepts that are, I'm sure, not new to you. But as a quick review, a ratio is a way of comparing two numbers to each other. And we have different ways of writing that comparison. Our first example here, we're comparing two numbers, A and B. And we can use the word to, T-O, to write that comparison to let us know that we have a ratio. We are comparing A to B. Another way of writing a ratio is using the colon sign. And that's also pronounced A to B. And lastly, another main way we have used to write a ratio is to use a fraction bar. And that fraction bar can also be pronounced with the word to, A to B. Ratios are helpful in helping us determine comparisons between numbers, especially when we use them against a comparison of another ratio. And when you have two ratios that are equal to each other, we have what's called a proportion. Well, first let's back up and think of an everyday example of a ratio. Let's say a person is 6 feet tall. Well, if we were to switch that over to inches, there's 12 inches in a foot. 12 times 6 would be 72 inches. Let's say that a person is 72 inches tall in real life. But then a picture is taken of that person along with some other people, and in that picture, that person is only 6 inches tall. So the bottom number here, 72 inches, represents their height in real life, but their height in the picture is 6 inches. So we can see that the picture shrunk the size of the image of that person from 72 inches all the way down to 6. We have a ratio here. For every 6 inches in the picture, it represents 72 inches in real life. Well, we take a look here at both 6 and 72. We can see that they both have common factors. And in fact, we can actually divide both the top and bottom by 6. So if we divide the top by 6, that would be 1 inch. And if we divide the bottom, 72, by 6, oops, it's not 16, it's 12. 72 divided by 6 is 12 inches. So we have a ratio here. For every 1 inch in the picture, that represents 12 inches in real life. This is an example of a proportion. Now that we know that that's what our scale is, let's go ahead and erase that because I want to look at something else here. We know that our scale here would be for every 1 inch in the picture, it represents 12 inches in real life. But let's say within the same picture, we have somebody who's 5 feet tall. 12 inches to a foot, 5 times 12, that person would be 60 inches tall. Well, in the picture that was taken, in the photograph that was taken, the photograph didn't take a look at the first picture, or the first person in the picture, and shrink him at one rate, and then take a look at the other person in the picture and shrink them or reduce them at a different rate. It's going to reduce them at the same rate or the same ratio. So we can actually use this first ratio to find out how tall this person would be in the picture, because these two ratios are going to be the same. They're within the same picture, and the photography shrunk both images at the same ratio. We have a proportion, 6 inches over 72 inches. We're trying to find out how many inches tall the person would be in the picture if they are 60 inches in real life. Well, a helpful property about a proportion is that this top number of this first fraction multiplied by the bottom number of this second fraction is going to be equal to the bottom number of our first fraction times the top number of our second fraction. And one way of thinking about that is cross multiplication. You may have heard that term in the past. This times this equals this times this. Well, there are some special names given. This top number in the first fraction and the bottom number of the second fraction are called extremes. The bottom number in the first fraction and the top number in the second fraction are called means. In a proportion, the means times the extremes, the product of the means equals the product of the extremes. So we can actually set up a formula here. And we can go 6 times 60. Well, 6 times 60 is 360. And now we have that is going to be equal to 72 times x. 6 times 60 equals 72 times x. Now that we've done the cross multiplying, we've multiplied our means and set them equal to the multiplication of our extremes, we can now solve this equation for x. We need to divide both sides by 72 to get the x by itself. So on the right-hand side, we're going to be left with x. And on the left-hand side, we're going to be left with 5. Because 360 divided by 72 is 5. So in this picture, in this photograph here, a person who is 60 inches tall will be 5 inches tall inside the photograph. This is the example of a ratio and a proportion being two ratios that are equal to each other. And then as the proportion has been written out, it allows us to use the cross multiplication property of the product of the means equaling the product of the extremes, and using that property to help us solve that unknown value there. Okay, this is just a quick review of what we just stated here on the previous screen. In this proportion, B and C are called the means and A and D are the extremes. And the relationship between this is that A times D equals B times C. Here's our next proportion. 6 over x equals 14 over 20. What is x? Well, we recognize that this is a proportion, so we're going to use our cross multiplication here. Our product of our means is going to equal the product of the extremes. So 6 times 20 is 120, and we know that that's going to be equal to x times 14, which is the same thing as 14 times x. Now we simply solve it for x. We divide both sides by 14. On the right-hand side, that'll leave us x. On the left-hand side, we have 120 over 14. We can reduce this. Both the top and bottom are divisible by 2. If we divide 120 by 2, that'll give us 60. And if we divide 14 by 2, that'll give us 7. 120 over 14 reduces to 60 over 7. So the value for x in this proportion would be 60 over 7. So we used the proportion to solve the problem for our unknown x using that cross multiplication. We can do the same thing here in this fraction, even though it's a little bit more involved. We have a polynomial now with two monomials in it, in both our numerator and denominator. How do we solve this proportion? Same way, we cross multiply. We multiply our extremes together and our means together and set them equal to each other. So we're going to have 10 times 2x plus 1. That's our extremes being multiplied together, and that's going to equal 3 times 5x minus 4. Those are our means being multiplied together. 2x plus 1 times 10, there's our 10 times the 2x plus 1, and then the 3 times the 5x minus 4, and that corresponds to this side over here. Now we just multiply it out and solve it using normal algebraic strategies. Let's go ahead and distribute this through. 2x times 10, 20x, plus 10 times 1 is 10. That's going to equal 3 times 5x, which is 15x, and 3 times minus 4 is minus 12. We're going to subtract 15x from both sides, so that's going to get rid of that 15x over here. 20x minus 15x is 5x. So we are now left with 5x plus 10 on the left and minus 12 on the right. We still need to get the x by itself. It's being added with a 10, so we need to subtract 10 from both sides. Well, that 10 minus that 10 will cancel that out, and minus 12 minus 10 is going to give us minus 22. Solving for x, we need to divide both sides by 5. X is going to equal minus 22 over 5. And at this stage in these lessons, I'm not going to go ahead and double check, but to double check your answers, you would need to take this value of x, stick it back into the original equation, and in this case, into the original proportion, multiply it out and solve it, and double check to make sure that that value is in fact accurate. Okay then, as a review, a ratio is a way of comparing two numbers. The ratio of a to b is written in algebra most often as a fraction bar b, a to b. A proportion, when two ratios are equal to each other, we have a proportion, and the proportion would be a over b is equal to c over d. And then in this proportion that's listed here above, b and c are called the means of the proportion. A and d are called the extremes of the proportion. And the principle or the property of a proportion is that the product of the means equals the products of the extremes. That'll wrap up session 101 on ratio and proportion.